Okay, good. So, Happy New Year. Welcome back.
Happy New Year.
Yes. Okay, so last week we were talking about rate of change, right? Then I told you the prerequisite. First one, mensuration. You need to know all the formulas involving area and volume. And in particular, to find surface area, you need to know about nets, right? A volume, for example, the cuboid here, can be broken down into hopscotch, this kind of pattern. If you imagine a cardboard box, you open up, you get a net. Then, of course, this can help you to find the total surface area, right? Total surface area. You need to visualize which are the squares, which are the rectangles. And then afterwards, you also need to know chain rule, which I've already taught you. Right? And just to help you, I included this slide. It's a summary of all the area and formulas you need to know. Do you need me to go through?
Okay.
Can Okay, very simple one. You know all this. Let's start with the 2D part. Oh, and then of course the 3D. Let me just write this down. 2D on the left, 3D on the right. So for the 2D guys, what we have triangle, square, rectangle, parallelogram, trapezium, circle. I'm sure you're familiar with all these shapes. I'll just quickly run through. How do you find the area of a triangle? Please take note that there are two formulas you need to know. Half times base times height, half AB sine C. Sine C, the C here being the angle in between. Okay, you are familiar with both? Yes?
Yep.
Find area. Then of course perimeter. If you are super confused, you can take a highlighter and then you highlight 1, 2, 3. Can you see the light blue highlights? A, B, C. If those lengths are like say 2 cm, 3 cm, 7 cm, let's assume that the triangle actually exists. It doesn't now, but okay, maybe 2, 3, 2, 3, 2, 3, 5. Yeah. Let's assume that this triangle exists. Then in that case, how do you find perimeter? Just 2 plus 3 plus 5. 2 plus 3 plus 5. Right? Can anything? So that is for the area and perimeter. Right, area and perimeter. What else do we need to know? We need to know about the next shape, square. How to find area? Just length times breadth. So L square. Then perimeter is 4 equal sides, so that's why it's 4 times of L. If one of the sides is length L. Then for rectangle, one side L, the other side W, different lengths, right? So you have to L plus W plus W. That's really just 2L plus 2W. Factor out the 2, you get 2 times of L plus W for the perimeter. And for the area, it will be length times breadth, L times W. But for parallelogram, this one maybe you forgot. For parallelogram, what you need to understand is there is a triangle here. You can always transfer it over. What shape do you get at the end of the day?
Rectangle.
Rectangle. So that's why it's the same area as a rectangle. So the formula for a parallelogram will just be the base multiplied by a height. B times H. Okay. But there's another formula which is B times A sine theta. Let me just zoom in a bit. Here, this formula, can you see why that's true?
A sine theta is H.
Exactly, very good. A sine theta is H. So this one, just good to know only. This one extra, don't really need to know all the time. Only B times H is the main one. Then for perimeter, it will be A plus B plus B, which is 2A plus 2B, and factor out the 2 times bracket A plus B. Moving on, trapezium. For trapezium, do you know this formula? Area. Yes, okay, just only. I'm sure you know all this. So whenever you have a trapezium, it means at least one pair of parallel lines. Also, in this case, length A and length B, parallel lines of length A and length B. Then the formula is half times the sum A plus B of the parallel sides multiplied by the perpendicular height here. Must be perpendicular height, not the D. It's the H. Okay, then for perimeter, very simple, just A plus B plus C plus D. Those 4 lengths don't have to be equal. Okay, they are not equal. So you just add them piece by piece. And then finally for a circle, you just pi r square. Pi r square for the area, where r is the radius. Then for the circumference, it's 2 pi r. But 2 copies of r is really just diameter, so it's really just pi d. Both formulas are fine. Right, you know all this, for triangles, just take note that there are 2 types of triangles you should know of. What are they? This one, and then this one.
Equilateral and isosceles.
Yeah, just take note. Just a side note only. The formula doesn't change. Okay, and of course, you know the 45, 45, 90 triangle as well as the 30, 60, 90 triangle. Those will help you to get the exact values. You need to know that. Oh, must go and okay, I didn't put it in the same page, but you can go and refer to it on your own, I guess. Yes.
Mhm.
Okay, then that's for 2D shapes. How about 3D? 3D, you have these shapes here: cylinder, cone, sphere, prism, pyramid. To me, cylinder is just a special kind of prism. Special kind of prism. Why? Let's just start with prism. What's a prism? Prism to me is really just a shape that has a cross-sectional base area, but you have an extra height. So that means that you just need to find that base area times height, or what they call cross-sectional area times height, to find the volume. Sorry. And a cylinder is just a special case of a prism where the base is a circle. So you use pi r square, then you multiply by h. Right, that's for volume. How about surface area? So this is a bit more complicated. Let's start with cylinder here. Let's start with cylinder about the surface area. In order to find the surface area, you need to draw the net, right? So that means that you can take this and split it up into this shape. Can you see that it's just one rectangle and two circles? Yes?
Yeah.
Can. That's assuming that you have what we call a closed cylinder. Closed meaning what? Closed means that you have a base circle, but the top, do you have the top?
No. Wait, yeah.
Close means yes, have. Close the lid, so you have a top lid, right? Closed. In the case where it's a closed cylinder, then you will have two circles. The area of each circle is pi r square, so that's why you have 2 times of pi r square. Then for the area of this rectangle, please take note that this part here that I highlighted in light blue, it will wrap itself around the entire circumference of this base circle, which means that this blue color part that I highlighted will really just be the circumference of the circle, 2 pi r. Is that clear to you? The length of this rectangle is 2 pi r. Can, good. Then how about this part here? Now it's really just the height of the cylinder. Okay, it's this part here, if you can visualize. Okay, so therefore the area of this rectangular part will be 2 pi r times h. 2 pi r times h. And to get total surface area, just add them together. Is it clear? Can? Okay, good. Now take note that sometimes you also have open cylinders. Open means what?
Open means not.
Not close, but more importantly, in terms of surface area, how many circles do we have for open?
1.
Only one, exactly. Only the base, only at the bottom, don't have the top. No top lid. So like, I mean, you can think of it as like, for example, you have a hemisphere on top. Okay, this is like a water bottle of some sort. Then there's a cylinder at the bottom, and then you have the hemisphere on top. So if you want to find the total surface area, what would it be? Assuming that this has a radius r, this one is height. Let's say h.
Pi r square plus 2 pi r plus 2 over 3 pi r.
2 pi r. Wait, 2 pi r times what?
2 pi r times height.
Last times height. Okay, maybe I didn't catch that. Plus the
2
curve.
pi r square.
2 pi r square. Very good. Because it's a hemisphere, the curved surface part. Okay, good. You will know how to do this, then I should go faster, huh? If you know this. Because here you didn't tell me 2 pi r square, it's just single pi r square. Why? Because we only have a base. If you imagine a water bottle, there is no extra circle over here, right? So maybe you're trying to figure out what's the total exposed surface area of the water bottle. Then this will be your formula. Okay, you must be able to visualize the 3D shape. Okay, that is for cylinder done. Prism surface area is just sum of all the areas of all sides. So basically, let's say we have a tent shape, which is a triangular prism. Then this will be the corresponding net. Can you see? 3 rectangles and 2 triangles. Now these triangles are very special. What kind of triangles are they?
These kind of triangles very special.
Yeah, and if these 3 lengths are equal, which is the same as those 3. In order for you to close the figure, right, these 2 lengths must be the same. So you get an equilateral triangle. That's only if that's only if this is a prism that happens to have a equilateral triangle, but it's not always the case. You can always have a prism that has an isosceles triangle base, like this. If I was on test of my art skills, if you can visualize the tent, can you see the tent? Like this. It's possible that this is an isosceles triangle, not equilateral. Okay, then if you want the net, it will just be 1 rectangle. And then let me see, I need to visualize this properly. This part will be a lot longer. Then it has to be the same length as the right side one. These 2 are equal, this one different. So like this, and then you have a triangle that's super long like this. So you can get the isosceles triangle. Must be the same length as the 2 sides. Let me just highlight it, green with green. And what else? Purple with purple. Can you see that the parts that are connected together must be the same length? Can, right? Okay, so that's a net. Then how do you find the total surface area? You just calculate the area of each piece. 1, 2, 3, 4, 5, add them all together. Then sometimes you also notice, oh, this triangle and that triangle area is the same. So you just find one of them, then you times 2. Okay, this rectangle and that rectangle area is the same. You just take 1 copy of the triangle, you times 2. The area of 1 copy of the rectangle, then you times 2. Then the middle rectangle, just find on your own. Right? You need to know this kind of things. Likewise for cuboid, the net is this guy, and then of course you just find the sum of areas of all the sides. All the what we call, sorry, this is not sides, this is faces. This should be called faces. When you have a 3D shape, the 2D area is called a face. If you know the terminology. Okay, wait, let me just do a quick one. What's the terminology? This part here is called a face. Those corners there, they are called vertices. Okay. What else we have? We also have the lengths. In this case, we call them the sides. Okay. The 2D area is the face. The corners are the vertices. So in a cube, there are 6 vertices and 6 faces. Then how many sides are there? Oh, sorry, not sides. Sorry, wrong word. Edges. How many edges are there?
8.
8. Nope. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12. 12. Okay, so in this case, let's just write down numbers. Oh, this one interesting pattern. Can you see our relationship? Face is how many? 6. B minus E plus F. 8 minus, what is it? 12 plus 6. Did I count wrongly? Maybe the formula is wrong. Yeah, I know this is correct. This is equal to 2, right? Do you notice that? B minus E plus F. Yeah. Okay, this is just something curious. There are other shapes that are similar to a cube. I forgot the name. I forgot what it's called. Similar shapes are I'll look it up and find out for you. But similar shapes to these will also have this pattern. If you take the number of vertices minus the number of edges plus the number of faces, it will always be equal to 2. Okay, this one just extra, don't need to know. Okay, box it up. Quarantine, don't need to know. Extra. Wow, it's always 2. Not sure why. You can go and figure out why and ask and tell me. Okay, anyways, we are done with cylinder and prism. Sphere, you also know it's a standard formula. This one no choice need to remember. 4 third pi r cube or 4 pi r squared. Alternatively, depending on your exam, the formula list will be given. For AMAX O level, the formula list gives these formulas for sphere and cone. Cylinder, I don't think so. Prism also not so also no.
Okay.
Okay.
I mean, cylinder and prism, I mean, just the area of the thing, then times the height.
Times the height, exactly. So it's quite simple. Right? Yeah, just have to times the height. Okay, then for cone is a bit special. You need an extra 1/3. Okay, for the volume, must have an extra 1/3.
Cone and sphere harder to remember.
Correct. Yes. Sphere got an extra 4 on top. Cone don't have, just a 1. Okay, then for cone, right, it's a bit special if you want to find the surface area. So let's figure out total surface area of a cone. In this case, pi r squared plus pi r l. L represents what we call the slant height. Then r is just the radius. Over here, there's a L. If you look at the diagram, this part is the radius of the circle. This L is the slant height. Then this H is the perpendicular height. Okay, so over here, if you take a cone and then you open it up, do you see that you'll get a sector and a circle connected at one point?
Okay.
Right, then this curvy part here, it will wrap itself around the entire circumference of the circle. Similar to the case where you have a cylinder. This blue color highlighted part will wrap itself around the entire circle. It's just that this time it's a curvy part that's wrapping itself around the curve, around the circumference of the circle. So that means that this curvy part here will have a certain what do you call it? It will have the length being the exact same as the circumference of the circle, right? Okay. Is that useful? Yes. Why? Because if you remember, theta equals S over R. Do you remember this? This is radians. The definition of radians. S being the curvy part here. Okay, let me highlight it. This part is S, then the R being this part here. This is R. Okay, then what else? Do you also remember the area of a sector? Area of sector. Wow, no space to write this down. Was this given in my list? Oh, it's not given. Sorry. Let me include it. Sector. You need to know the formula. Sector is just a watermelon or slice of pizza like this. Radius R, angle here is theta. The curvy part here being length S. Then definition of radians tells you theta equal S over R. The area of this sector is half R squared theta. Remember this formula?
No.
Okay, good. So if half R squared theta, you know this formula, then you know how to apply it to find the curved surface area of a cone. So let's take a look. Over here, curved surface area of a cone. The watermelon here. It must be half R squared theta, right? But what's theta? Theta is S over R, right? So I can replace the theta over here with S over R. Can you see? The theta got replaced with S over R. Then what will happen? R squared and R will cancel off, right? Cancel off. What are you left with? Erase. You're left with R times S. R times S. But wait a minute, what's S? S is this green part here. The curve, sorry, what do you call this? The arc length, which happens to wrap itself around the entire circumference of the circle, and therefore it is really just the circumference of the circle. So that means that this S will be replaced with, what's the circumference of this circle? Oh, sorry, I labeled wrongly. This is not Did I label wrongly? Is this L? Is this R or L? This should be L, right? Can you see? Slant height here is L. Oh, sorry. Let me try again. Oh. Maybe it's not so easy to derive the formula. Right. You need to use a proportion argument. Okay, I'm going to skip that. Sorry, I have to skip this.
Okay.
I'll just add you. I'll explain it another day. The reason why the formula for the curved surface area of a cone is pi r L, where the L is over here, not R. This part is L. Sorry. Explain another day. But if you accept that, then pi r L here will be the curved surface area of the cone. But then you have a base, right? The bottom here, which is a circle, and therefore the area is really just pi r squared, with R being the radius. Right? Can? Okay, good. So let me just take a look. Why did I write this here again? Oh, it's for this guy. Okay, very messy. Very messy. Let me just move it away. Oh no, that's not good. I can't move it away. What do I do? Give me a second to move this away so the notes look a bit better. Okay, I'll copy this now. Like this. Exposed surface area. Okay, good. Okay, back. So where was I? I was talking about cone and the surface area. You just take the curved surface area, pi r L, and you add on the base area, which is a circle, so pi r squared. Then for sphere, we talked about it already, right? Did I talk about it? 4 pi r squared, right? No choice, need to memorize. Can 4 of them done. Now we move on to the last one, pyramid. For pyramid, it's really the same as a cone. It's just that a cone is sort of like a special case of a pyramid. Like this, special case. What's so special? It's that for a pyramid, the volume is just 1/3 times the base area times the perpendicular height. But for a cone, it's a special case where the base area happens to be a circle. So it's the same relationship between prism with cylinder versus pyramid with cone. One of them is the special case of the other. Can you see that?
Yeah.
Can Yeah, then to find the surface area, again, you just need to sum all the areas of all the faces. So in order to get the faces, you need to draw the net. Okay, let me just write a note here. Draw net. Draw the net and you'll be able to find the total surface area. Okay, good. And then this part about conversion of units are not important. Please ignore. Okay. And actually, to summarize all the formulas, right, you only need to know 4 things. 4 things. Okay, let me just let me try and write it somewhere. Volume will always be base area times the height for normal shapes. Normal, then what's not normal? Not normal will be things like sphere. This one, no choice, need to memorize. For sphere, the volume is equal to 4/3 pi r cubed. What else is not normal? What else is not normal? Pyramid. Pyramid is not normal. So sphere is just a ball, I guess. Okay, for pyramid, you have to think of it generally as can be any kind of base. So if it happens to be a circular base, what do we call it?
You call it I don't know, 1/3. I just know it's like 1/3.
CONE, cone. Traffic cone. Orange color traffic cone. Okay, but the English name is not important. Yes, but yes, correct. You just need to take the base area times height formula, then you times the extra 1/3. That's all. So really just, did I miss anything? Yeah, I didn't miss anything. That's all you have. That's all you have. 3 formulas only. But then the base area here, if you have, okay, this one is called a prism. This one is called a prism in general. If you happen to have a circular base prism, then you will need to change the base area here to pi r squared. If you have a circular base in this pyramid, then you will have to call it a cone, and you just change the base area here to pi r squared. Okay?
Okay.
Can yeah. Good. Just keep this somewhere in your mind, and we will move on to the application. Okay, I just copied and pasted the rate of change questions. I also marked your work already. It was all fine. You know how to do. Let's just move on to the medium level questions. Do you have the stringly file open?
Okay.
Yeah, go and. Oh yeah, have you read that work example 1314?
No.
No, okay. We can go through that, I guess. Oh, I need to go and get the photo as well. Give me a second. All right, the Maristella one. I think I will go through it another day. Okay, not so important. I want to go through rate of change. Okay, Ken, let's go through these examples, then you should be able to do the questions. Let me change the size first. Okay, let's take a look. Connected rate of change. Okay, basically, you just need to know that we are using chain rule, but in a funny way. For example, if you have dy by dt, you can always split it out as dy over question mark, then times d question mark over dt. The trick, the top one goes here, the bottom one goes there. Then you just need to fill in the blank, the question mark, with something that's the same. So it can be anything. It can be like dr. It can be d something, d whatever. Doesn't matter what it is, as long as these two can cancel off each other. Sort of, in a sense. Can be x. Okay. What else do you need to know? You also need to know that if you want dt over dy, this will really just be 1 over dy by dt. Sort of like taking the reciprocal of a fraction, right? Yes?
Yeah.
Can you know these two? Okay, then now let me move on to application. Work example 13 and 14. So let's take a look. The radius of a circle increases at a rate of 0.2 cm per second. So what does that mean? Means d what by d what? Okay, so the answer is given here already. Yeah. dr by dt. Do you know why?
Because radius over time.
Radius over time. Yes. Correct. That's it. So it's just a matter of translating from the English sentence into a math equation. When you see the something of whatever increases at a rate of whatever, those are the keywords. This first guy that is changing, this will appear on the numerator, the top, upstairs. Okay, at a rate of 0.2 cm per second means the right hand side. This is the right hand side. Oh, maybe I should be consistent with my arrow. This should be your right hand side value. So equals to the 0.2. Then this is the numerator. By numerator, I mean it will be the radius. The numerator will have the radius. But you have to over d something. In this case, what's the something? By default, if they never say, right, you see the sentence, they didn't say with respect to whatever, then the denominator will always be time. it will always be time by default. You can also tell that it is time because of the units cm per second. So it's radius divided by time, cm per second. Can? Radius is like the length of physical quantity, and cm is the units representing the physical quantity. This is from physics. You know this idea?
Okay.
Length, then you have cm or meters. The SI unit is standard, international standard unit is meters, but we use cm. This is called physical quantity. I'll use QTY to represent quantity. Then this is the units. Okay, length will use cm. And time will use seconds or minutes or hours, represented by the symbol S. Okay, this is centimeters represented by cm. Meters represented by m. Yeah, you know this, right?
Yeah.
Can okay, then I don't elaborate so much. Here they are a bit more formal, so they define what is R and what is T and what is whatever before they start using, which is the proper way to do things. Let R cm and A cm square be the radius and the area of the circle respectively. They should also, if they want to be formal, they should also say let T seconds be the time that has passed. Okay, but I'm not gonna be so formal. Is that okay with you?
Yeah.
Can okay, good. So over here, as a result, you get dr by dt equals to 0.2. Next, they're asking you, calculate the rate of increase in the area when the radius is 5 cm. Oh, right. One more thing to take note. Here, they said increase. That's why you have a positive, invisible positive sign in front of 0.2. What happens if they said decrease instead?
Minus.
So they will phrase it as decrease at a rate of 0.2. They won't show the minus sign. You have to automatically put down a minus in front of 0.2 on your own. Is it clear?
Yeah.
Put the minus on your own if they say decrease. So that's prelim questions you'll see. They always like to trick you, students. But anyways, this is easy, just positive 0.2. Then we have to write down the formula A equals pi r squared, right? What do you want to find? A equals pi r squared is fine, right? Just recall from the table I showed you just now. Then you want to calculate rate of increase in the area when the radius is 5 cm. Let's start with the beginning. Let's start with the ending first. What do you want to find? Rate of increase in the area. What does that mean? We want
area over time.
So A over time. Oh, by the way, please use a capital letter for area, okay? It's a convention.
Okay.
Can use capital letter. Also, do not use two letters like surface area, use SA. No. Just use a single letter. Okay?
Okay.
Here, let me just write this down. Two important notes. Single letter only. Do not put two letters for this derivative notation. Sorry, you must come up with a good single letter that can represent whatever you're trying to represent. In this case, area, so capital A. And capital, yes, it has to be uppercase. Okay, so dA by dt, then you realize, the original equation is A equals to pi r squared. Don't have T, don't have T. So what do we have to do? We need to do the funny trick. Remember the funny trick? This one? So that's when you have to apply it. So you split it up, dA at the top times dt at the bottom. I know it is not actually a fraction. dA over dt is not a fraction, it's a derivative if you want to be formal, but for all practical purposes, it is. You can just pretend that it is a fraction and you can think of it as cancelling off something. So now what is that question mark that we should fill in with? What should we fill in the question mark with?
dr.
Why dr? Why do I want dx? Why do I want dy?
Why do you
choose
dy?
Yeah, exactly. What is dy? That's the question. There is no y to begin with, right? In this question.
We have dA over dr.
We have dA over dr. Yes, correct. We can find that from A equals pi r squared. Oh, sorry, I forgot to do that. We can differentiate and we get this by r. You know how to differentiate, right? I don't need to go through.
Yeah.
This one, okay, good. So you get 2 pi r. Take note, this is not d. I noticed one of the homework you wrote down dA by dx instead of r. This is wrong because there is no x. There's no x. There's only r as the independent variable. A is the dependent variable. So it's in D. Okay. So yes, that's why we have dA by dr. That's why we want to fill in the question mark there with dr. Because we have. What else do we have? dr by dt. It's also given, right? It's over here. So there are two ways that we can figure out it's we're supposed to choose dr. First one, I think more obvious, which was what I was expecting you to tell me, but it's because it's given. dr by dt was given. That's why you want to pick r. Then if this you found out it's dr already, the bottom must be dr, which means that we need to have dA by dr. How do we obtain dA by dr? So we can just proceed to differentiate the A. Okay, sometimes you can work a bit. Of course, math can go in many different directions. You don't have to follow the order that I said. You can just differentiate straight away, dA by dr. Then you realize, oh, I have dA by dr, so no choice. This one must be a dr. Okay, good. Can understand how I chose the dr?
Yeah.
Can, okay, then now we just proceed with the substitution. The rest is easy already. The easiest part, just substitute. dA by dr is 2 pi r, dr by dt is 0.2. Multiply, you get 0.4 pi r. But wait, what did the question say? The radius is 5 cm. So can we just stop at 0.4 pi r?
Sub in 5.
Cannot. Very good. You must sub in the 5. Then finally, you simplify, you get 2 pi. So the rate of increase in the area is 2 pi cm square per second. Now take note, you do not substitute the radius at the beginning. So what some of my students did before is A equals pi r square. They see radius is 5 cm. They don't bother differentiating or anything. They just immediately sub r equals to 5. Then A equals to pi times 5 square, 25 pi. Then dA by dr. Oh, okay, so that means dA by dr when r equals to 5, dA by dr equals to, just differentiate 25 pi. D by dr of 25 pi. But as constant differentiate, you get 0. So this is 0. Then the answer is 0. 0 cm square per second. Correct or wrong?
Wrong.
Wrong. What's wrong?
I mean, like,
What was the first step that led to all the things that went wrong?
never differentiate.
You never differentiate. You're answering the negative. So what did he do at the very beginning?
He sub into he sub in the 5, which is into the area.
Correct. Yes, that's it. That's why what the student did wrongly. Substitute at the very first step. Wrong. Please remember this idea, okay? Do not substitute as your first step. Differentiate is your first step. Okay? Okay, not really the first step. I mean, you see A equals pi r squared, then differentiate. That's like a third line already. First line is to copy down what's given to you. And maybe if you want to be even more formal, you have to define your variables. Let r cm be, let A cm square be, blah, 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 blah. I will skip that step because I'm sure you know A stands for area, R stands for radius. Don't need to say. Okay, you know that, right? Do you? I'm assuming you know that. Okay, good. So let me just write this down. The mistake here. This is very important. Instead of differentiating. Bad. Differentiate first, sub later. Good. Okay, differentiate first, sub r equal to 5 later. Okay, that is the example done. Any questions?
No.
No? Okay, now we go on to the true question that will be the kind of questions that you should see normally. Is it a bit blur? I don't know. Hopefully you can see. Sorry, give me 1 minute, Ken.
Yeah.
Give me 1 minute. Okay, I will need to make this into a background. Just gonna share. Can see?
Yeah.
Okay, good. Ken, let's take a look at the next example. This is the medium level question. Okay. A hemispherical bowl of radius 8 cm is completely filled with water. The water is then transferred at a steady rate into an empty inverted right circular cone of base radius 8 cm and height 16 cm with its axis vertical. Given that all the water is transferred in 5/1/3 seconds and that VCM cube represents the amount of water in the cone at any time t, find t seconds t. In dv by dt in terms of pi. Then part 2, the rate of change of part A, the height of water level. Part B, the horizontal surface area of the cone when the depth of the water is 6 cm. So this depth of 6 cm applies to both part A and part B. What does all this mean? So confusing. Please,
Yeah.
I expect you, when you see this kind of question, they start telling you hemisphere. They tell you inverted right circular cone. What are you expected to do as your first step?
Differentiate.
Okay. Maybe can I introduce step 0 instead? Draw a picture.
Okay.
Draw a picture. Very important skill you must learn. Draw a picture. Don't just jump in directly without drawing a picture because you're going to be using similar triangles. You're going to be using similar triangles. You better draw a picture. Okay. So let me go through how I solve this first. So first one, hemispherical bowl. Oh, hemi means half. So I just draw half a bowl. Okay, maybe this first part not so important. Radius 8 cm, I'll just label 8 like that. Filled with water, fully filled. Oh, how come my bowl upside down? How to fill water? Cannot be. So curve downwards. Okay, good. Now can fill water. Okay, water filled in. Now, what's more important is you can figure out what's the volume of water. So in this case, 2/3 pi r cube. If you recall the formula for a sphere, it's 4/3 pi r cube. So for hemisphere, it's half, right? That means you just have to divide by 2, so it becomes 2/3. Okay, that's why over here is 2/3 pi r cube. Then you can find the volume. Take note, your answer must be in terms of pi, so that's why the pi was left alone. Is it clear enough? 3, 4, 1, 1/3 pi.
Yeah.
Can see cm cube. Okay, then after that, they tell you for part 1, find dv by dt in terms of pi. So since the volume here is a constant, right? That means that when we want to find the rate of change, all we need to do is to use the tan triangle. Do you know what's a tan triangle?
What?
Total average rate number. Yeah, it's just a general version of DST. Do you know DST? Distance, speed.
Yeah.
Right. And how to relate them together. You want to find distance, it's speed times time.
Times time.
You want to find speed, it's
Distance over time.
By time. Distance over time. You see the fraction over here? T over T. Then of course you want to find time, you take distance over speed. Same idea here, but it's in terms of rate. So average rate, in this case, what do we want to find? dv by dt, right? That's really just the average rate. Okay. because rate of change of volume is a constant. How do you know it's a constant actually? This part. Why?
How do you know it's constant?
Yes. How do you know it's a constant?
How do you know it's constant?
Because of read the second sentence. The water
The
is
water is being transferred at a steady rate.
steady rate.
Steady rate.
That's it. Yeah. That's all. Steady means constant. Yeah, they
Okay.
could have made it less confusing by just saying constant, right?
Mhm.
Yeah, but okay, just adapt accordingly to the question. So constant rate, that means that we can just use a rate, the tan triangle that we all already know. It's like this is just a very fancy way of saying if you work more time, then you will produce more output. Makes sense, right? Like if you are a worker, you're able to pack 2 apples, some blue color apple, into 1 box per minute. 2 apples per minute. Then if you work for 10 minutes, how many apples can you put inside the box? How many apples can you put all together? 2 times 10, 20. Right? So in that case, your TAN, total average rate, and the N. Sorry, I can't spell N. Okay. Your A average rate will be 2 apples per minute. Then the number here will be 10 minutes. How many minutes? Number of minutes. Then the T total here will be total number of apples. Does it make sense? TAN?
Yeah.
Very simple. Okay, good. So likewise over here, it's just even though we say dV by dt, because it is pouring in the water at a steady rate, that means that this dV by dt is the constant A here. That means you just need to take total divided by number and you get your answer. So total here is total volume. Then the bottom here is total time or number of minutes. Okay. Let me just label this part here is your T, this part here is your N, this part here is your A. Okay, then T over N, how do you know the N is 5 1/3? Because the question said so, 5 1/3 seconds. All right, all the water is transferred in 5 1/3 seconds. So you divide and you get your answer. Ding. Clear so far for part 1? Is it okay?
Yeah.
Okay, so in case let's just recap what's going on first. So we start off with this hemisphere. Then after then what's going on? What's going on is that there is water that's filled up all the way. Water is then transferred at a constant rate into an empty inverted right circular cone. What does that mean? It means the student, once you read this, please draw a cone. Please draw a cone. How to draw a cone? Like this, right?
Mhm.
But here they say inverted. Inverted means terbalik, terbalik. Flip it upside down. 倒反. I don't know. Like this. Can? So what if we slant it? Can also. Why cannot? Cannot. Because they told you right circular cone. What does right mean? Right means not it's not you tilt the cone to the right or whatever right means. Right means it must be can you imagine a center line a center line,
Mhm.
the vertical axis. They said okay, and also they mentioned axis vertical with its axis vertical means that you cannot make it slanted. It must be vertical line, so up and down. Okay, and right means you don't have a cone that looks like this. Can you see the difference between these two? What's the difference? This is the let me mark it in green now. Where's my green pen? Oh no, what's going on? Green center of the sorry, what do you say? You say anything? Do you write anything?
Nope.
Okay, so what's the difference between these two?
I mean, this one is like, I don't know, this one is like 90 degrees here, but this is different. This is like, I don't know, this is like weird.
Yeah, okay, let me label a different color. This time, this top corner of the cone is the red point. What's the difference between these two?
Is this one slanted?
Is it slanted? No, okay. What do you mean by slanted? Correct idea. Your idea is there already. Describe it in your own words.
Like, I mean, this one is like straight down. Like, there's a right angle here.
Okay.
But this one is like built different.
Yeah, okay. I think what you're trying to say is if you draw a horizontal line like a diameter across the circular base that passes through the green color point, and then you drop a perpendicular black color vertical axis down from that green color point. Let me color in my green again. For the first cone, there is a red color point that's the, what do you call it? The vertex of the cone that will intersect the line. Correct? There's a 90 degrees here. So a horizontal line across the green, and you drop a vertical, it will intersect the red. Whereas the other case, if you draw a horizontal line through that same green center of the circle, and then you draw a black color vertical line down, it doesn't pass through the red point. Can you see that? Left side is what we call a right cone. This is not right. I don't know a name for it. It's not slanted. I mean, slanted can mean a few things. I mean, if your cone is like this, a right cone, and then you tilt it a bit, it's also slanted, right? Slanted, right? Okay. It also looks slanted. So slanted doesn't have a proper definition. Okay. So only right has a proper definition. Right is a technical word. Maybe you should put capital R. No. Math make it a common noun already. Little r. Right cone means that the what do you call it? The vertex of the cone is directly above or directly below the center of the base. Did you catch that?
Yeah.
Okay, I'll just write it down here. The vertex means the red color point is directly above / below, depends on how you turn your head, how you draw the diagram. The center of the circle. Circular base. Okay, wait, let me spell it correctly. Circular. Okay. Yeah, so we will never see this kind of question unless it's a very, very difficult question. We will usually not deal with this. Way too complicated. The formula for the volume will still be 1/3 base area times height, but the rate of change will no longer be constant. It's a lot more complicated. We don't talk about non-right pyramids, non-right cones. Cone being a special kind of pyramid with a circular base. So we focus on this guy. All right, understand empty inverted right circular cone now? Good. Okay, what did they tell you? They said that this cone has a base radius of 8 cm. So that means that over, if I just erase all this, okay, maybe I'll leave the green point there. This part here is 8 cm, also, which is the same as the hemisphere. It's the same. Okay. Then what happens is water from this hemisphere, this bowl, is transferred at a steady rate into the empty cone. So water will fill in. Right? Can? Now I know what you're thinking. Maybe, from a real world perspective, if you pour water in, the water will keep sloshing around left and right inside the cone. It won't be stable, right?
Yeah.
But let's just assume that it is. Let's just imagine that the person who's pouring the water has very steady hands. Or you're using a machine. Then it's just slowly filling up so that at every single point in time, the water that's inside the empty cone will form itself a cone shape. Can you see the green color, light green highlight cone shape I'm drawing? Yeah, so every single point in time, every time you pour in a little bit, the water itself will form what kind of shape? What kind of shape? The water itself?
Cone.
A cone. Okay, very good. Can you understand already? Okay, so if it does form a cone shape, right, that means that we can start to draw in this water with the empty cone. Sorry, the water, how do you call this? The cone made of water and the empty cone container. Okay, then we carry on. Let's read the question. Part 2, part A. Find the rate of change of the height of the water level. What does that mean? Where's the height of the water level? Can you label on this diagram? Where is my height? Correct. Okay, for when you are doing doing exams or whatever, just draw dotted line like this, and then label like this.
Yeah.
Height for H for height. It's a very common symbol. All right. So what do we have to do? What are they asking us to find? The rate of change of the height. So d1 over d1. Right? Every time you see rate is d something over d something. So what are those question marks?
Rate of change of the height of the water level.
So what's
dh
the top?
over dt.
Very good, dh over dt. Do we have a formula for h? Can differentiate in terms of
formula for h?
Have
can make one.
We can make one, yes, but not directly, right?
Not directly.
Not. I mean, yeah, it's not directly. Is there a formula for height? Do you look at the list of formulas? Don't have, right?
No.
You only have area and volume.
Can use the volume for.
Yeah.
Okay.
Can use the volume. Okay, but actually, maybe let's just think of a trick we can do before we proceed. Do you know what I mean when I say trick?
Of the trick.
Look, part 1, what do we find already?
dv over dt. Okay.
So what do you want to split this dh by dt up into?
Can make it into dv over dt times. Wait, make it 1 over dv over dt. Is that right? Wait.
That will give you dt on top, dv below. Is that right? Is that how I taught you to do the trick?
Wait.
No. Take a pen.
Okay.
Write 2 fractions. Very good. dt below. Good. Much better. See, once you do follow the procedure I told you, split it into the top left and bottom right, everything is very simple. Okay? Can don't waste time trying to figure out which is which. Just split it up straight away. That's a standard trick. Okay? Can? Good. So yes, this is dh over dv then times dv over dt. Very good. That means if we know part 1 dv by dt, we can sub in here. If we know dv by dh, then we can continue. But there's a problem. What's dv by dh? V is volume. Is there a formula we know for volume?
Yeah.
V for volume. I shouldn't write it here. No space. Okay. V for volume. Let's just write it here. Sorry, I hope you can follow. Very messy. V for volume, right? So what's the volume? Volume of the water, right? Which is a what shape? What shape is the volume of the water?
Cone.
Cone. So what's the formula for the volume of a cone?
2/3. Wait. 4/3 pi r
No.
square.
Oh no.
Wait. 1/3 pi r square.
Pi r square is area only, cm square only. We want cm cube times the height. Very good. Okay, good. What do you notice? Here, wow, a bit more complicated. I got r, got h. Can we just sub in the r now? You see depth of the or sub in the h. See, depth of the water is 6 cm. It's really telling you h equal to 6. So can we sub in now? Yes or no? Sub first before you differentiate? Can we do
No.
that? No, so
Differentiate.
let me just write this down first. At this stage, do not sub h equal to 6. So what were you saying? Differentiate. Differentiate what thing? D what over D what? We start with V, so D
dv over d
over D what again?
d
Confused, right?
yeah.
You should be confused here because for the first time you see a formula got two letters. R is a variable, H also variable. Then how to continue? dr dv over dh. How to continue? Don't know. So that's why the question started off. The question immediately jumped into this is after you are very familiar with the procedure already. Then straight away you use similar triangles. But I'm trying to give you the thought procedure. Why do you need to use similar triangles? The reason is you are stuck at this stage. When you want to differentiate, you realize that this formula involves two letters, two variables, R and H. In the future, you'll learn about this thing known as partial differentiation. Future as in not in A Max, not in A level Max. It's only in university. Then you will be able to take partial V over partial R, partial V over partial H. This is a topic known as multivariable calculus, or what we call calculus 3, vector calculus. Don't need to know yet. Okay, whenever you see two variables, two or more on the right hand side, you are not allowed to proceed with the normal differentiation already. This is not allowed. Are we clear? Let me write this down. None. Because multivariable equation detected. You're like a robot. You have detected what? You have detected two or more variables on the right hand side. The V is still a single letter, so as per normal, but the right hand side is a bit weird. Got two different variables, two or more variables. Once you see this, you know there's a problem. You cannot proceed with dv by dr or dv by dh. None of the above. So that's when you need to do a trick. You need to do a substitution, a clever substitution, so that you can convert from this multi-variable, two different variables, two or more in the future, you'll get more complicated. For now, it's just two. From these two variables into just one single variable. Okay? But which variable do you want to keep?
H.
Why? Very good, correct. Remember the trick we did just now? What's the problem we encountered? dv by dt, we know it from part 1. But dh by dv, do we know it? Don't know. But we need dv by dh. So that means that dv by dh is really just 1 over dv by dh. That means that we need, what this really means is we need dv by dh. Can you see the pattern? Can you see the trick? Can you see what we need? It's dv by dh. Clear? Not dv by dr. I don't want dv by dr. I want dv by dh. Is it clear to you?
Yeah.
Okay, good. So if you know that you need dv by dh, from chain rule, it's called chain rule, that trick that I just did. I'm just going to copy it and paste it over first. From chain rule, we know that we want dv by dh. So we don't want dv by dr. All right, good. So that means that we want to keep the variable h. Keep variable h. Oh, sorry, I said something, but I didn't write this down. So, oops. Another trick. Do a clever substitution to eliminate variable R keep variable h. Why do I want to keep variable h? Because I want dv by dh. Why do I want dv by dh? Because 1 over dv by dh is dh by dv. Why do I want dh by dv? Because of the chain rule trick. Is the logical flow? Are you following the logical?
Yeah.
The flow of the logic? Okay. Can. Then, wow, very messy. Yeah. This one keep variable h. I should write it on top. Let me just bring it down a little bit. So what is this clever substitution that I keep talking about?
I don't know.
So the clever substitution is already shown in the answer key. It's over here. You need to realize that if you zoom in on this cone, these two cones are essentially, if you take a slice of, if you imagine you can slice the cone in half, can you imagine a rectangle? Maybe you think of it as you take a chopper, then you slice it right in the middle. So you slice the cone into 2 equal halves. Can you visualize the slicing? Then the intersection between this rectangular piece of, I don't know, maybe paper or something, with the cone is really just 2 triangles. Can you see the intersection? Can you see the triangles?
Yeah.
So that's what they're trying to depict over here. Can you see these 2 triangles? Can see it? There's a rectangular piece of, there's a piece of rectangle that just slices the cone in half, and the intersection between that rectangle with the cone forms these 2 triangles. And they are similar triangles. You can prove it because of AA similarity test. There's a 90 degrees here, there's a 90 degrees here. There's a common angle to those 2 triangles. So there are 2 angles that are the same. AA similarity test tells you it is similar. You don't need to prove it's similar. I think it's obvious. Right? You're not required to prove the similar triangles. So once you know it's similar triangles, what's so special about it? You know that this is height h. You also know that this is radius r. Correct or not?
Yeah.
So that means you can form an equation from similar triangles. R over h equals to 8 over 16. Sorry, I didn't explain where did 8 and 16 come from. 8 came from the question, radius of 8. 16 came from the question as well, height 16 cm. Sorry, I forgot to label. Let me just label it now. 16, 8. Is it clear how I got the 8 and 16 from the question? Okay, yeah, so let's just look at the nicer diagram that they draw. So there's a 8 here and a 16 there, which means that there's you can compare with the R and the H, which gives you R over H equals 8 over 16. Is it clear so far?
Yeah.
Using similar triangles. Can? Or you can also think of it as R over 8 equals H over 16. Exactly the same. Exactly the same. Double arrow means identical, logically equivalent. So as a result, we get R equals to half H. Is this clear to you? Just times the H over 8 over 16 is half. Good. Why did I make R the subject? It's because I want to keep which variable? I want to eliminate which variable?
You want to eliminate R.
Good. And keep the H. Yes?
Yeah.
So if you, how to eliminate R? You have to replace the R. That's why I made R the subject. For convenience, for convenience. You don't always have to make R the subject. Just make sure the R disappear and keep the H. So that's why over here, the 1/3 pi R square H formula, involves R and H. So irritating. I only want H, I don't want R. What do? I found a formula for R. I substitute it in over here. Let me write it in a clearer format. 1/3 pi R square H. The R gets replaced with what? Half H. But what's half H? Half H is actually just H over 2, right? So you can rewrite this part inside the bracket as H over 2. Okay? Then continue expanding. 1/3 pi times H square over 2 square, then times H. Correct or not? Following so far?
No.
Yes, huh? H squared times H will then become 1/3 pi times H cubed over 2 square. But what's 2 square? It's just a 4. So H cubed over 4. Then 1/3 times 1/4 here, there's a 1 on top, invisible 1. So you can think of it as 1/4 times 1/3, you get 1/12. So pi over 12. Okay, maybe I write 1/12 first. Then times pi, then times H cubed, which is pi over 12 H cubed. Is this part okay?
Yep.
Very good. So now if this is the volume in terms of H, we can proceed to dV by dH. Then the rest should be familiar, right? Let me just explain in case you're not sure. Pi over 12 is just a constant, so you can just factor it out. I mean, it's a constant factor, not a constant term. Then you just use power rule on the H cube. So bring down the old power 3 minus 1 to get the new power 2. So 3H squared. Pi over 12 times 3H squared. 3 and 12 cancel off, you get a 4 at the denominator. So pi H squared over 4. Okay?
Okay.
Okay, yeah, so now we can just, okay, this one they did it a different way. I like to do it my way, which is start with the conclusion. What do you want? dH by dt, right? Over here.
Uh-huh.
So here's how I do it. For this part, I would say dH by dt equals to dH over something times something over dt. I think, and then I realize, oh, I have dV by dH. So I can just put a dV at the bottom and the top. But this one dH by dV, that one is dV by dH. So they're upside down. Then I also flip it upside down. 1 over pi h squared over 4, which is 4 over pi h squared. Is it clear to you? I just flip it upside down.
Yeah.
Right? V on top, h below. Now h on top, v below. Flip it, just flip it off. 4 over pi h squared. Then times dv by dt. Oh wait, dv by dt I remember from before. dv by dt was, let me just see again. dv by dt was 64 pi. Right? From part 1. So I just sub in 64 pi. Okay. I haven't sub in the h equals to 6 yet. Right? I'm still following what I told you. Do not sub in the h until you differentiate. I've already differentiated. So what do you think you want to do now?
Sub in now.
Yeah, exactly. So sub in h equal to 6. You can simplify if you want, but yeah, you can also directly substitute in. So the next line we will have to write down dH by dt, draw a line, h equals 6. So it's 4 over pi 6 squared times 64 pi over 1. So the pi can cancel away, right? Then the rest is just use a calculator and you get your answer. Should be 719. Okay? Can?
Yeah.
Yeah, good. That is part A done. Let's move on to part B. Find the rate of change of the horizontal surface area of the cone. So how? What is horizontal surface area? Can you shade in for me on this diagram? Where is the horizontal surface area of the cone?
Horizontal surface area of the cone.
Oops. No, wrong. That one curved surface area. Horizontal means the sun rises above the horizon, left, right line.
Wait.
Yes, correct. Yes.
Oh.
Yeah. So let me just highlight horizontal surface area is referring to this part. Okay? Is it clear?
Yep.
Okay. Yeah. So we need for another formula if we want to find the rate of change. Can you tell me what am I trying to find first? D what over D what?
You're trying to find dA over dt.
Very good. So trick, split it off. What do you think you want to split it up as?
dA over something over dt.
Yes. So you're confused, right? What do? Write down the area of the formula for the area. What's the formula for the area?
Pi r
Base area
squared.
times height. Oh wait, don't need just the area of a circle. Don't need to times height because we are looking at area only. So pi r squared. Okay. Then how to continue?
2 pi r
What's that? 2 pi r is what? What's on the left hand side?
dA
Sorry?
dA over d dA over d what is it? dA over d
What is it?
what is it?
Is it x?
No.
You don't see x here. What's the letter?
Yeah, no such thing as x.
What's the letter here?
What is it?
R.
R.
Do you understand why it's R?
Why is it R?
What were you thinking of instead?
What was I thinking of instead?
Yeah.
Oh.
It has to be R. Okay, maybe that's not a meaningful question. What I mean is, usually what you have seen so far is like y equals x cubed. Then just bring down power 3x squared. So dy by dx. But the reason why you put y on top here is because it's on the left-hand side. It's the dependent variable. Okay, then why do you put an x at the bottom? It's because it's the variable on the right-hand side. Can you see the color coding, the red and the green? So likewise over here, this is the red color dependent variable, A. Then the independent variable is R, the green color one. Can you see the dA by dr? Pi is just a constant. Pi is like pi, you can think of it as 3.14. Like it's just like a number 3.14. Then when you do when you differentiate with respect to R, the 2 go down and minus 1. So it becomes 2 times of 3.14. Then times R power 2 minus 1, which is really just R. That's our times. Don't need to write. Is it clear?
Yeah.
But of course, we want exact value lah. Don't use approximation 3.14. So we use the exact value, which is a pi, which is a pi. Is it clear? Can so R at the bottom because the variable is R. Okay, very good. Then how? What do you want to pick here and there?
dA over dr times dr over dt.
Exactly, right? Because you already have dA by dr, you can just substitute in over here. But what's dr over dt?
Go back. Wait, we don't have dr over dt.
What do we have instead?
What do we have instead? We have dv over dt.
What else do we have from part A? Part 1 gave us dv by dt. Good.
Yeah.
Part 2, part A, we already solved part 2, part A. What did that give us? Huh? What do we find? Rate of change of the mic test. Can you hear me?
Yeah.
Tell me.
Of change of the height. So
D what over D what?
dh over dt.
Yeah, that's what we have. Very good. Can we use that? Can of course How? So maybe we shouldn't pick dr over here. Is there a smarter choice? right? We are free to choose. You chose dr because it was easy to differentiate with respect to r. But what if we purposely made our life a bit more difficult so that we could make use of dh by dt? Okay, this is getting quite messy. Let me start a new page. Is that okay?
Yeah.
Can I give me a second? What should I do? Okay. Okay. Wait. And I need a copy of the question. Yeah. dv by dt is found from part 1. Part 2, part A, dh by dt was found instead. Part B asks us to find dA by dt, where A is referring to the surface area of the cone, horizontal surface area. So we start with dA by dt. We realize that maybe we can fill in the blank with dr. Why? Why do we want to fill in with dr? Because we realize that a equals pi r squared. That's correct. And then we can find dA by dr naturally. So that means this part is okay, dA by dr. But then dr by dt, question mark, question mark, question mark. Don't know how to find. Cannot continue. What does this tell us? It means that instead of picking r or dr, how about dh?
dA over dH.
Yes. So that means this time, instead of picking dr, we replace with dh. Let me just write it down first before I continue talking. Why is this a better choice?
Because we don't have dr over dt.
Okay, and more importantly, this fellow. Do we have it? dh by dt?
Yeah, we have this our part.
Exactly. It's right
Part
here.
A.
Then how to find dA by dh?
Is it the similar triangle thing?
Yes. So if you recall the similar triangles, what we had just now was, oh yeah, if you're lazy, you don't want to draw 3D cone, you can just draw similar triangles like this. But
okay.
yeah, up to you. We had a 8 length here, length 8 cm here, and a length 16 cm here. We had a length r here, we had a length h here. Let me just label first, and then we conclude r over h equals 8 over 16, r equals to half h. Now, a equals pi r squared, we can find dA by dr there already. But what if we made our life a little bit more difficult? A little bit. I just replace the r square with half h squared. Can I do that? Of course I can. Then what do I get? Let's just work it out first. H squared over 2 squared is 4. So it's pi over 4h squared. Can see? Is it clear? Pi over 4h squared? Why do I want to do that? Because now that I have converted it from the R world into the H world, let me write this down. Convert. You like time travel, you take an aeroplane from the R world into the H world. We are able to find dA by dH. How to find dA by dH?
dA over dH, how to find? Can go to the previous
Previous?
here. The other page.
The other page. Which one? Which part?
Sub in the. Okay, go back down, go back down.
Just differentiate. Why? Okay,
Okay.
I give you an analogy. Y equals to pi over 4x squared. Can you find dy by dx?
Okay, yeah. Wait, yeah.
What's pi over 4? It's
Pi
a
over 2,
constant factor, so don't need to do anything. And how to do? Then you just have to multiply by
2x.
d by dx of x squared, which is 2x. Yes. Then pi over 4 times 2x, then you get pi, sorry, x. So you get pi over 2x. How about dA by dh now? Just replace the y with a and the x with
Wait, d over dh.
yes. So what's your answer again? Sorry.
That's the
Huh?
part where you sub in the like. Okay, never mind. Okay.
Sub in. Later, last step.
Pi over 2, pi over 2h.
Yes. Correct. Oh, do you say that already? I didn't catch that. Sorry.
No, I
Yes.
didn't say that.
Oh.
But
Okay.
I'm just like, I don't know, my brain not working.
Yeah. It's the same. It's the same. So you just need to know what are your constant coefficients, or the like pi over 4 in this case is a constant coefficient, and you need to know who's your variable. In this case, h is a variable with a power 2. So differentiate h square, you get 2h. Pi over 4 times 2h, pi over 2h. Okay? The letters will keep on changing, so you must be you must adapt. It's not always y and x. Okay? All the questions I've been giving you were too simple. Always involve y and x. But now it gets more difficult. It changes to a and r. Then you must understand that pi is not a variable. It's just a constant. And it's a number. So you just factor it out. Right? Leave the pi alone. Okay, anyways, you got pi over 2h already. So we can happily substitute in pi over 2h for the dA by dh. Then dH by dt. We found out previously already. Let's see what was the answer from part A. dH by dt was 7 and 1/9. Okay, so I just write down 7 and 1/9. Is that the final answer?
Yeah. Wait, no.
No.
No, sub in.
So you still need to sub. H equals the depth was 6 here. So H equal to 6. Okay, depth means height. Same thing. Can? Are you following? Yeah. So you just sub in h with 6. Of course, you can write the notation dA by dt, draw a vertical line, h equal to 6. And you get pi over 2 times, pi over 2 times 6 times 7 1/9. Then you can simplify and get your answer. Let's look at the answer key. What did they do? Okay, they did the same thing as me. A equal pi r square, but then suddenly become pi h over 2 square. Where did the h over 2 come from? Oh, you recall from the similar triangles. R equals to h over 2. So you sub in. Get this guy. Then after that, you can find dA by dh, which is pi over 2h. Okay, then when h equal to 6, you just have to sub in. Okay, here they substituted when you before doing the chain rule, which I slightly disagree with. Okay, I slightly disagree with. You should only be substituting at the very end. Okay. Like okay lah. What I mean is dA by dt given that h equals to 6 is equals to dA by dh then times dh by dt, this whole thing, okay, given substitute in h equal to 6. This will be equal to dA by dh, then you sub in h equal to 6 times dH by dt, then you sub in h equal to 6. But it just so happens that dH by dt when h equal to 6 was the answer 7 and 1/9. Okay. So they did it piece by piece, which is okay. I guess it's fine as well. dA by dH when h equal to 6, they get 3 pi. Did I do something wrongly? Let me just double check. Oh no, nothing wrong. Yeah, I just didn't simplify 6 and 2 become 3. Okay. Can understand what's going on?
Yeah, my brain just
Noted.
yeah.
Okay, actually there is still one more way to do it. Let me show you. dA by dt. We started with dA over dr and then dr over dt, and we realized that there was a problem. Dr by dt we cannot find. dA by dr we can find, right? That's from the first part. But wait, there is actually another thing you could do. If we use chain rule, this splitting up trick one time, why can't we do it again? What's stopping us from doing it again? So this part that we have a problem with, which is dr by dt, why don't we also split it up? dr over question mark times something question mark over dt. Split it again. Split once not good enough, then split again. This is our second method. What do you think you want to pick now? This one.
dr.
Huh? dr?
No,
then it will
no,
cancel away, become 1. Not
no,
so.
no. Why?
Huh?
dr d
Pick
d
another letter.
dA.
dA. Well, then you get dA square, a bit difficult. And how do you relate A to time?
dr over
dH.
dH.
Yes, exactly. So it boils back down to the second method again. So dH, yes. So we can actually find dA by dr, dr by dH, dH by dt, piece by piece, and then we can answer the question. We already know dA by dr. This was part 1. It's a constant. dH by dt, we also know it was part 2, part A. Right? Remember the 719? Right? dA by dr was the what was dA by dr again? Let me double check. dA by dr. What was our answer to dA by dr? Oh, right, it's over here, 2 pi r. Right, pi r squared dA by dr becomes 2 pi r. So we can sub in with 2 pi r. Then all that's left is the middle guy. What's dr by dH?
dr over dH.
So whenever you see two letters R and H, the letter at the top, letter at the bottom, it means we need an equation where the top guy is the left-hand side, so R equals. Then the right-hand side is a function of H, f of H, so that we can find dr by dH, which is f prime of H. Okay, I haven't been using the f prime notation, so I just hope you still remember this notation. The notation not important. More importantly is to know that you need a function, an expression in terms of H. Do we have a formula for R in terms of H?
Yes.
Yes. Right over here, all right. Can see I got half H, remember? Yes, very good. So we can use that over here, half H. Then what's dr over dH?
Yeah.
If you're confused, imagine the R is a Y. The left side is a Y. If you're confused, you imagine the right side H is a X. So Y equal half X, then dy by dx.
Okay.
Which is?
Isn't it just half?
Exactly, it's just half. Yeah, that's why I'm waiting for your answer. Half. Let's work it out. Let's multiply all this and see if it works out. 2 times half is 1. So we are left with pi r times 7/1/9. But what's r? We are only given depth is 6. How? How do you find the r? What do you have to sub in with? We are only given dA by dt given h equal to 6. What is depth again? Sorry, it's h, right? So this is really h equal to 6. How do we find r? If only there was a magical formula that converts from h to r.
There is.
This guy, right?
Yeah.
So you just sub in now. So what's r? Half times h. Half times 6. Which is 3. Okay, so we get pi times 3 times 719. Eh? That looks familiar. Pi times 3 times 719. Scroll back up. 3 pi times 719. Eh? It's the same. Do you understand what's going on? Yeah, so there are two ways to do this. You either go for the direct way, which is pick r is not good enough. Then you change the letter, change to h. That's the moral of the story. That's the method 1. Method 2 is you use chain rule 2 times, which is what I've just shown you. Okay, this one r cannot, so you change the r to h and then it works out. Or r cannot, but you persist, you keep on using r, but you do chain rule a second time. So now this time the dr by dt split up into dr over dh times dh over dt, so that the dh cancel away. Then you have to figure out piece by piece, substitute in terms of the letter r. Then finally you sub in with r equals to 3. But wait, how do you get r equal to 3? We only given depth equal to 6 cm. You had to use the formula. Is it clear? Second method a bit more complicated. Right, you use chain rule 2 times. Right, the r cancel away, h cancel away. You're just left with dA by dt. Can you see that?
Yeah.
So you can actually imagine how many, you can just introduce as many letters as you like. Right? Just imagine dy by dx, you're not happy, you split up. So you introduce a dA. dA not happy, you introduce another letter. dB. dB not happy, then you introduce another letter. This one split. What letter would you like?
What letter I like?
Just for fun only. Pick a letter, any letter.
G.
G, okay. Then how do you split it? dB by dx, try writing. Yes, and DJ again. Yes, exactly. Let me just write it out for you so that you can have a reference. DB, no, DB cannot be. You introduce what? I'll use a different color. DJ, is it? Yeah. So you can imagine it keeps going forever, right? Cancel. You're just left with dy over dx. Okay. Clear? This is chain rule. You don't need to know the extended version. Just method 1 is fine. Moral of the story is many things. Let me summarize some of the few key ideas you need to know. Ayo, this one extra. Let me just toss it aside. Key ideas. Number 1, draw a picture. They tell you hemisphere, they tell you cone, just draw. Hemisphere. Once you have the picture, you know what to do. Use formula from the table. What table? What table? Scroll this table, these two tables. Okay, understand? Use these tables, the formulas from these two tables. Can? All right, not enough. After you use formula, then you have to start to differentiate. So like for example, A equals to pi r squared. Then you just differentiate with respect to r. See whatever is available, just differentiate. Do it first. Then maybe it might be useful. Sometimes it isn't. In our case, it wasn't useful. We had to instead be clever. Clever trick. It's a very common trick. Use similar triangles to convert. Or maybe before I talk about this clever trick, I need to talk about how I know I need to use this clever trick. I got V equals to 1/3 pi r cubed times h. Then I want to find dv by d, question mark? How to continue? Got two letters, got r, got h. Both cannot. Why? Because got two letters on the right hand side. So we cannot continue. Stuck. Let me just write this down. Stuck. So that's when you need step 4, which is a clever trick. You need to use similar triangles to come how do you call this? Actually, this is called multi-variable into single variable. Multi-variable calculus into single variable calculus. What does that all mean? It basically means R become half H. So everything is in terms of H, only one letter. Are you clear about this step? Only one letter remains. Pi is not a letter. Okay, it's a letter in the Greek alphabet, but I mean letter as in a variable. The letter is not accurate. It should be a variable. Variable. Okay. So that you can tell that it's not. I'm not talking about pi. Pi itself, yes, it's a Greek letter. Greek letter got Greek alphabet has like what 24 letters. Pi is one of those letters. In the Greek language, they have a Greek alphabet. Pi is one of those letters. I'm not referring to that Greek the pi. I'm referring to the R and the H. Are you clear on what I'm referring to? The R here and the H here. Two of them. Too difficult. Multi-variable. Multi means two or more. We don't want to deal with that. We want single variable, one only. So we have to come up with similar triangles, and then we realize R over H equals 8/16, if you recall. And then finally we get R equals to half H. That kind of thing. All right, good. So you can convert from multivariable into single variable, and then you can proceed to differentiate as per usual. As per usual. Okay, then the rest is just use the standard rate of change trick. The what do we call the chain rule trick of the fraction trick. So like what was it? dH by dt then become dH over dV times dV over dt. The V can cancel away. But of course, you don't introduce already and then you cancel away lah. You must really use it. dH by dV is 1/dV by dH. You can find dV by dH, then you can flip it around to get dH by dV. And dV by dt, that one was from part 1. Okay? Clear? So DIY, find it yourself, or maybe FIY, find it yourself. FYI is for your information. FYI is find it yourself. Okay, good. Time for examples. Let's go into the Xingli workbook. The PDF I sent you, rate of change, medium level questions. if I go through all the questions, then I will just assign you homework from the other textbook. Okay, can you open the file? You got the file open?
Yeah.
Yes. Okay. We'll go through. I see. Which question should I go through? Should I go through? I'll start with 6. I'll start with 6.
Okay. Container
This is questions.
HCM volume given V CM given by V equal 1 H square bracket H plus 4 given the depth of water increases at rate of 2 cm per second, find the rate of increase of volume when H equal 5. You want to find dV over dt.
WTF is 1 to 5. Yeah.
Okay.
dV by dt.
Given the depth of the water.
When, wait, sorry. 1 to find dV by dt given or when what happens?
When H equal 5.
H equal 5. So you need to sub in H equal 5 as a first step or last step?
Last step.
Last step. Okay. Last step. Okay. What was the given 2 cm per second?
Depth of the water increase at rate. So is it
so,
dt over dt?
No. Please don't use. Okay, actually can if you want. But I don't want to do it. I'll just use H.
Over. Yeah, okay.
Why do I use H? Because the question already mentioned the depth of the container is HCM. They already used the letter H. Don't follow the question. Yeah. Plus or minus this one? -2 or +2?
Increases, so plus.
Very good. Yes. Positive because increases. Sorry, that 3 letters that 3 dots that I just wrote, dot, 2 dots at the top, 1 dot at the bottom to form a triangle. This is because. Do you know this?
Yeah.
And 1 dot at the top, 2 dot at the bottom is therefore. I told you already. How fast? Okay, can carry on. What do you do? First step.
Okay, so V equal
Copy the formula. Step 0, copy the formula. Step -1, -1. Then 0. Then differentiate. dV by?
dV over d
H, yes, not X, but H. Why? Because that's the only letter available on the right hand side, right? Single variable H, so it must be a H. The variable on the left appears on the top. Variable on the right appears at the bottom. Can?
Yeah. Product rule.
Product rule. Actually, okay, can.
Wait, it's not how? Oh, you just expand inside. Okay, yeah.
Yeah.
Okay, that's way faster.
Yes.
Okay. Plus 4.
Notice something. I didn't multiply the 1/3 in. Why?
Because it's scalar rule anyways.
So you just have to leave it alone. And times
3h squared plus 8h.
What's missing?
What's missing?
A pair of
bracket.
Very important. Okay, yeah, that's it. You don't need to multiply a 1/3 in. Leave it alone. Then how to continue? Find what? WTF? dV by dt.
Yeah. dV by dt equals to dV over blank times d sometimes blank over dt. Then you have dV over dH, so put dH, and then you put dH over dt. Okay, yeah, now then you can just sum in equal to 1/3 times bracket open 3h squared plus 8h bracket close times 2.
Very good. Yes.
Yeah,
Okay.
then you can just sub in h equal 5, and that's your answer.
So vertical line h equal to not 6, 5. Yes. So you don't even need to simplify lah, huh? Just this step don't need to simplify lah. Just copy and paste and then substitute the h with a 5. Some of my students are faster. They will just directly sub in with 5. They differentiate already. They don't even bother writing this down. They don't bother writing this down. They just give me the final answer here. But can I strongly encourage you to find this and then this? Okay, give me the derivative without substituting the h, then you sub in the h. Okay. Yeah, so whatever it is, I don't care. You can type in a calculator and get the exact answer. Let's move on. Okay. Question 7, is that? Okay, we can try question 7. Yes. This time something weird happened. The equation changes to a p times v equal 3600. Wow, how come the left side got 2 letters? You read the question first.
Okay. It's P. Gas in container changes volume according to P. P is number of units of pressure, V is number of units of volume. Given P increasing at a rate of 20 units per second at the instance when P equals 40, calculate the rate of change in the volume of this instant. So you want dV over dt.
Good.
And then
at this instance, so when
P equals 40.
Good.
Okay, so then
given
they give you P dP over dt equal 20.
Positive or negative?
Positive, increasing.
Very good. Here the units per second they never tell you, but if you're studying physics, it will be pascals.
Okay.
Never mind, don't need to know. I don't teach physics. I don't need to tell you. Just units can already. Then how? This one can differentiate or not?
It will just be 0.
Yeah, just be 0. Let me ask you, your left hand side, have you ever seen 2 letters before?
No, bring over the P. V equals to 3600 divided by P.
Very good.
Differentiate dV over dP equals to minus 3600 times P to the power of -2.
Good.
Okay, then now you have wait, let me okay, yeah. Now you can just use that times 20 to get dV over dt. Then sub in P equals 40 inside, then you get answer.
Very good. Yes. Because dV by dt is what you want, you just split it up with the dP. And that's really just the -3600 P power -2 times the dP by dt, which is 20. Oh, by the way, this can also be rewritten as -3600 on top all over P square. Not important. But yes, just sub in P equal to 40 and then you're done. So dV by dt is P equal to 40. So I'm just going to copy and paste this, but replace the P with a 40. Equals to ... answer. Can? Good. Okay, then the rest should be, question 8 should be quite fine. I'll skip it. Question 9, okay, question 9, this one you need to think a bit. Question 8, homework. Question 9, let's go through this. The base of a closed rectangular box is a square of sides x cm. And maybe you read on your own first.
Okay. Base of course is a square of sides x cm and height of box 8 cm. Okay, given the size of square, base increase at constant rate of 0.05 cm per second, find rate of increase in volume and in total surface area when total surface area of box is 210 cm squared.
Yes. So first step, you should always please draw a diagram. So let me just draw it for you for the sake of time. This is cuboid. So what is going on? What they're telling you is that
height 8 cm.
what's going on is that the cuboid is growing. Okay, can you see? The square length is growing longer and longer. All right. Then what is it? Okay, but you don't need to draw so many. Just draw one can already. Okay, let's just focus on the small one. What did you say? 8 cm. Okay, 8. Oh, sorry, that's the height. X cm is the base. Then how? WTF and given.
Okay, what to find? They say find rate of increase in volume and in total surface area.
Oh, so it's 2 in 1. They are being greedy. There's 2 questions in 1 question.
It's like part 1, part 2, is it?
Yes.
Okay, so first find dV over dt. Then the second part is find dA over dt.
Good. But both are the case when
dA, both are the case when total surface area is 210.
yes. Yeah, correct. Let me write that down. A equals to 210. A equals to 210. Okay. So what's given?
Okay,
Part 1, part 2.
given is the constant rate of
So d what over d what?
sides of square. dr.
Did they give you a letter for the
dx over dt 0.05.
positive or negative?
Positive increase. Okay.
So far, you haven't encountered a decrease. Later, we'll have water dripping out from a cone.
Okay.
Just now it was a bowl, then water go inside the cone. So water level is increasing. So that's why it's positive. But later on, we'll start with a cone that already has water, then water is dripping out. So the height is decreasing. So negative, just to take note. So very good, 8x squared. Yep.
Equal to 16x times 0.05. 16 times 0.05.
Huh? 16 times 0.05.
16x times 0.05.
16x, yes, because you're introducing what letter? I want you to show this step. Show this step. Don't just times.
Okay.
Dx, yes. Which is 16x times 0.05. And then finally, dv by dt equals to, when what? When a equals to 10.
Wait. Okay.
There's no a to sub in there. How?
No. A. Okay. Wait.
We need to figure out what's the formula for a.
Total surface area. Total surface area is
square, rectangle.
2x squared plus 4 times 8x.
Yep. Oh, sorry. Yes, correct. Because there are 4 copies of. Yep. Which is
2x squared plus
32.
32x.
Yep.
Okay. 2x squared plus 32x equals to 10.
Yes, correct. So sub a equals to 210, which means your 2x squared plus 32x equals 210, and solve for x. So bring over, divide by 2 if you want to, or just use a calculator straight away. Yeah, just use a calculator straight away. What do you get? X equals quadratic, eh?
Yep.
Type.
You get x equal 5 or x equal negative 21. Reject x equal negative 21 because length cannot be negative.
Yep, correct.
Okay, then 5. Okay. So sub x equal 5 into the 16x times 0.05.
You got your answer already. Good.
Yep.
Okay, move on. Next. So what's so challenging about this question? Oh, sorry, we need to move. Oh, haven't do part 2 yet. Sorry. This is part 1 only. What's challenging about this question is that you need to know how to draw a cuboid. And then you need to know what are they giving you. It's dx by dt. You can come up with your own letter R. Use the letter given. Then you need to know the formula for the total surface area. So use the 2 tables I gave you. Yeah, then after that you need to know you have to equate to 210, solve for x. So there's a lot of layers to this question, right? A lot of different topics combined together. You see that? Chain rule also. Then your differentiation technique, you better make sure you know it already. Must know all the techniques like in the, how do you say it? Like and from the bottom of your heart, or how do you say it? You must know it very, very well. Okay. You need to know how to differentiate this like instantaneously. If I wake you up in the middle of the night, like 4 a.m., I shake you away. How to differentiate 8x squared? You must be able to give me 16x straight away. Okay? Because that's only the first step. You still got all these other things to do. Okay?
Okay.
Okay, let's move on to part 2. So dA by dt.
Okay, 1 dA over dt equals to dA over blank times blank over dt. You have dv over dt.
dv.
Okay.
This part okay, this part not okay. How to find dA over dv?
Okay, 1 over dv over dA.
Then how to find dv by dA?
Okay.
V is in terms of x, not a.
Okay. Now mind change dA over dx times dx. Wait. Hold up. Okay. Yeah.
Yeah, much better.
over
dx by
0.0.
correct. And then dA by dx is? Do it at the side.
You have
A.
formula for A here.
Exactly. So you can find dA by dx, which is
4x plus 32.
very good. Then you can just sub in 4x plus 32. I hope it's
Then
getting
after,
easier.
just
And then last step.
sub in x equal 5.
I don't like to write English words, so I like to use symbol. Vertical line x equal 5. Okay, then 4 times 5 plus 32 bracket times 0.05 equals to whatever. Okay, I think you're getting the hang of it. Let's try another question. Let me see what's a good question. Question 10 should be okay. Question 11. Let me read first. Okay. No, 11 is easy. Okay. The question 12. Let me see. Okay, we can try question 12. Question 10, 11 homework. 10, 11 homework. Let's try question 12. Okay, when the height of liquid, you read yourself.
Okay.
Let me drink some water.
When the height of liquid in the tub is x meters, the volume of the liquid is V meter cube, where V equals to 0.05 times bracket open 3.
Don't need to read, Okay, you read it, silent reading. Let me know once after you're done reading. Let me solve the question together. Yes. Okay.
Which is dV over dt.
Yep, correct.
Given.
Well, I recommend you to write down the WTF and the given on the right side. Like, so you have space on the left side for your working.
Oh, okay. V equals 0.05 x plus 2 minus a.
What rule? What rule?
What rule?
Just carry on. It doesn't matter. You can use any rule you like. As long as it's correct.
Scalar rule. What?
Scalar, yeah, correct.
Wait, what do you mean what rule?
No, I'm just trying to get you to think
this
how to
becomes
differentiate.
chain rule.
Hold on. 0.05 multiplied by a square bracket means it's a scalar factor, so you can just factor out. Then you just differentiate the inside, and now it's something cube. So yes, chain rule. Carry on. Okay, I don't distract you. Good. Minus 8 becomes a 0. 3 is 9.
9 times 0.05.
So 0.45.
Is this right?
Correct. Very good.
Okay.
Yes.
Yeah, then this okay. What? Wait, find an expression for
yeah, it's just expression. Sorry, I think the formatting is wrong. The part 2, the given is for part 2. Okay, so the WTF. Sorry. That was.
Okay.
This should be for part 2.
Rate of which. So find T over. Wait. Height dx over dt. Find
Yes.
dx over dt when we have this and this. Dx over dt equals 2dx over blank times.
Oh, you use x. Hold on. Why is it? Why do you use x?
Find the rate at which
right. They gave the height as x. Sorry, you're correct. I was wrong.
But then how dv? But okay, then the 1 over whatever thing.
1 over the upside down version. Yes.
Okay.
reciprocal. Good, good.
Go to 1 over turns
dt. Very good.
I will do the notation but no space.
But can you substitute there?
No. Okay, wait. V equals 0.95.
Correct.
So mean this thing
Volume of what shape?
95.
Yes. They didn't give you a shape, but they gave you the formula. So you just equate to 0.95. Then what do? Solve for?
Find x. Then after you find x, you do x equal this one.
Then you sub in. Correct. Substitute the x to dx by dt. Do you know how to solve for x in a cubic equation? This one only got a single cube, so should be okay, right?
Isn't it just like make it and then
Yeah.
like this calculator?
Calculator. This one cannot
Yeah.
use. I mean, yeah, you need to use the cube root function, but there's no direct way to key in.
Wait, I thought can like as in
Can.
like not from this, but like you just make it into like cubic equation. Then
Standard. You mean standard form? Standard form. A x cubed plus b x squared plus c x plus d. Then yes. There is.
yeah.
Actually, don't need Okay, I show you how to solve this without calculator. Let me see. Okay. So don't erase anything. 0.05. Let me copy down first. 3x plus 2 cubed minus 8 equals 0.95. This one, you must understand you can peel off layer by layer to reach the x. So over here, 0.05 is a multiplication. So bring over becomes a divide, which means you're left with whatever is inside. Let me just copy and paste this. Equals to 0.95 divided by 0.05. Let me use my calculator first. So it's a 19. Okay, then I can bring this minus 8 over. So I'm left with 3x plus 2 cubed equals to 19 plus 8. Okay, 19 plus 8, what do I get? 27. So 3x plus 2 bracket cube equals 27. Don't need calculator lah. Just take a cube root. I mean, don't need to use that calculator solve cubic equation mode. Just normal cube root can already. You're left with 3. Then x equals to 3 minus 2 divided by 3. Okay, negative 1 third. Negative 1 third, positive 1 third. Sorry. Can? Yeah, then you know the rest, right? Just substitute.
Yeah.
Okay. Can. Let me
But
just.
this is so different from the one just now. Why is the one just now like super long and like?
Okay. I guess I haven't reached the correct level of difficulty yet. Let me continue going. Let me scroll
Just now
down.
it's like built different.
Yeah, it's totally different. Oh wait, this one maybe too easy. This one, question 13 homework, a little bit different, but you can try it. Question 14. Yes. Question 14. Maybe I should change the difficulty. I should move it to difficult. Question 14. Let's try. Finally the water is speaking. Okay, so let's read the question. Can you read it silently? Let me know once you're done.
Oh my god, this again. Oh my god. Water leaks. Okay, so minus 5. Wait, so
Let's write down, sorry, answer
dV
the part one
over
first,
d
express V.
for
Wait,
express
before you do that, let's try and answer part one first. Express V.
volume of water in a cone in terms of height. Okay. 1/3 times 8. Wait, 1/3 times pi 8 square. Wait, in terms of height h.
Is
Wait.
it 30? 30? Wait, height is 30, correct or not?
No, because wait. Let me think.
What's V? Volume of?
Water, not the cone.
Very good.
But then how do you know what's the radius? That's only like not only be like the
So let
one
me, so it's good to introduce letters. Radius, what letter would you like to use for radius?
R.
R. So where's the R? Can you label on my diagram? Where? Sorry, try again. Yes, over here. So label like this, R. Like this, arrow diagram. How about the height of the water? Where is it? Can you draw? Yes, good. Okay, you can extend the dotted line. If you're going for engineering, mechanical engineering or civil engineering or that kind, you're gonna be using computer aided design, AutoCAD, that kind of whatever software you use. You're gonna need to draw this kind of helping lines, dotted lines. So I think you should get used to drawing this, like D and T, extend like this, so it looks very nice and tidy. This is height H. Okay, can okay, maybe a computer can help you to draw, so maybe you don't need to know how to draw it manually, but you should learn how to draw it manually, the nice way, roughly nice way. Computer will be, of course, the nicest. Okay, then how? Is this correct? Definitely wrong. This is volume of the entire cone. We want the volume of the conical shaped water.
But then
So the R is wrong, H is wrong.
yeah, but then you don't
So it's
give
just
any value for
R and H, just R and H.
But then the R is like you make up your own self one.
Can, you're allowed to do it.
Can? Okay, can then.
Yes. R for radius of the water. You can just define it on your own. Let RCM be the radius of conical shaped water. Conical shaped water. Let HCM be the height of the conical shaped water. Sorry, I didn't do this. Yes, you are allowed to introduce letters on I guess I was just being lazy. I didn't want to write English sentences. Okay, but you get this, right? R for the radius, H for the height of the water. Okay, then that's it. That's the volume. So is that the answer?
Yeah.
Wrong. They want in terms of height H. It means purely in terms of height H. Okay, maybe the question wasn't being precise enough. They meant purely in terms of height H. So H, okay. R, not okay. I don't want R. I want to keep only the H. I want to eliminate the R. I want to keep the H. What should I do? Oh, let me just draw water leaking.
Does it have something to do with the 5 cm cube per second?
The what? Say again?
The 5 cm cube per second.
That's for part 2. No.
What's this?
What triangles are there?
Oh, similar triangles.
So from this diagram, not enough. Can you maybe, I think it's nicer if you just draw a pair of similar triangles like this one and this one. Can you try drawing? No, in the same orientation, same orientation. And yes, then label the relevant lengths. Label the 90 degrees. Good for my equation. Very good. In terms of h, so good. So r equals to 8 over 30 h.
Over 30. Yeah.
4 over 15 h. Yeah.
Okay, so sub that into here. Done.
You draw it nicely. 8 30 r h, r over 8 equals h over 30. R equals to 8 over 30 h, 4 over 15 h. Okay, sub in, what do we get? Let's do that. So over here we get this guy, but you replace the r with, what is it again? 4 over 15 h bracket square times h. Maybe I should put the square outside like this. Is it clear? The substitution?
Yeah.
So it's pi over 3 times 4 square is 16, 15 square is 225, h square times h. So we get h cubed, 16 over 225 with a 1/3. I need a calculator for this. 16 over 675 pi h cubed. Is that okay?
Yeah, in terms of h.
Good. Part 2. That's when you can use your 5 already. WTF and given. Okay, maybe I just show up to here.
Find dh over dt.
WTF.
When h equal to cm.
Given?
Given 5, which is dv over ds. I mean dv over dt minus 5.
Very good. Minus 5. I was waiting for the minus. Yes.
Yeah.
Very good.
Then you can find dv over d. Wait.
Do the trick. Do the trick.
dh dt dh of dv dh over dv. Nope. Go to 1 over dv over dh. dv over dh.
Good. Carry on.
dv over dh, you can use the one from part 1 and you just differentiate that to get dv over dh.
So give me the answer.
So it's just 32 over 675 pi h squared.
30. Sorry. 30. Say again.
32 over 675 times 5 times h. Wait.
42.
Wait.
48, you mean?
Yeah, 48. Yeah. Or then 5 h squared.
Okay, good. Yes.
Sub in h equal to
1 over this guy. So
yeah.
please be careful with the fraction, okay? It's 1 over the entire thing. Then times 5 or negative 5?
Negative 5.
Negative 5. Okay, very good. And then finally, dh by dt, you have to sub in with, what is it again? H equals to 12. Okay, so let me just sub in the entire thing with a 12. Okay, then you can try to get the exact form. Then that's it. You will get a negative value as your answer. So what does it mean when you get a negative value? Negative value. dH by dt is a negative. What does it tell you about h? H is a what function?
Which is a
Negative means less than 0. Is a what function?
decreasing function.
Does it make sense? H is a decreasing function. The height is a decreasing function. As time passes, the height decreases. Does it make sense?
Yeah.
Makes sense, right? Water is leaking. So the water level is dropping, so the height drops. Okay, good. So you must make sure you always have this kind of logic at the back of your mind. Is the water being poured into the cone, or is the water leaking out of the cone? Leak out, negative. Fill in, positive. That kind of thing. In terms of the height or the volume. Clear so far? Do you want me to show you the exact form? You don't need to. This is fine. This is fine. I'll accept. As long as you can show the substitution. The rest is just algebra. It's not even algebra anymore. This one is like Sec 1 math. You can simplify on your own. Okay. And good. Okay. Then okay. Yeah, I think you actually the difficult question also not that difficult. The rest will be your homework, and that will be all for today.
Then why the Tesla one so difficult?
Because you are seeing it for the first time.
Okay.
Yeah. Actually, no. Actually, that question was a bit more difficult. You had to do a substitution with the what is it?
Yeah, you had to like substitute the.
Yeah, for especially for the part A, you have to do a substitution to the R to get it into purely in terms of H.
Yeah, then there was also
but that's part 1, right? That's part 1. Express V in terms of H. The part that's different is this part B, part B. You need to convert into H first and then dA by dH, which is a little bit more difficult. Yeah, I think I'm not sure if you'll get to see that kind of difficulty in question 15. Okay. Can?
Yeah.
Yeah. That is all for today. Just to let you know what's gonna come up next. So after you're done next week, I will go through whatever go through your homework, whatever you have done, any mistakes. Then after that, I will start, if possible, I will want to so I have to go through the Mario Stella. There was a few questions that were wrong. I will start new topic, which is on optimization. Find max or min. This is one of the most. Sorry?
Still differentiation.
Still under differentiation, yes. This is one of the most important topic that you will have to remember for life if you're going to engineering. Except for computer science and computer engineering. All other branches of engineering, you need to know this. Okay? Computer science, maybe somehow they can avoid differentiation, but all other branches of STEM, you need to know. Okay? This is one of the most important topics. Tune in next week. Okay, that's all for today. Bye-bye.
Okay, thank you very much.
Thanks. Bye-bye.